The absolute value of u is defined as if u is positive, you get u back. When u is 0, you get 0 back. And when u is negative, you get minus u back. So we have to put a negative sign in front of u. So we're going to use this definition and calculate the definite integral of absolute value of x squared minus 1 dx, as x is ranging between -2 to 3. As usual, we're going to go back to algebra and analyze y equals to x squared minus 1. When you set this equal to 0, x squared minus 1 is 0, or x squared is 1, or x is plus minus 1. It means that the graph hit x-axis at 1 and -1. And since the leading coefficient is positive, it opens up. So at 0, you get a -1, and you have 1 and -1 on x-axis, and this is the behavior of your graph. So this is y equals to x squared minus 1. It is not the absolute value yet. For the absolute value, we have to be analyzing this curve where y is negative, where y is positive, and so on. So first, let us begin by negative part. As you can see, your y is negative down here. But what is the interval over which your y is negative? Remember that the graph hit x-axis at -1 to 1. So between -1 and 1, as x ranging between -1 to 1, your y is negative. So we can simplify this absolute value. The absolute value of x squared minus 1 can be written as, when x is bounded between -1 and 1, your y is negative. Okay? -1 and 1, my y becomes a negative value. It means that I have to multiply this quantity by a negative sign. When x is equal to -1 or 1, my y value is 0. And in any other interval, your y is positive. So what are those intervals? Let's take a look. So from -infinity to -1, my y is above x-axis. My y is positive. When your x is more than 1, your y is also positive. So you can write it this way. You can say that, hey, as long as my x is more than 1 or x is less than -1, I get the exact same quantity back. I get x squared minus 1. Very good. So let us graph the absolute value, all right? To graph this absolute value, you have the following. Just need to flip the negative part with respect to x-axis. Since y is negative between -1 and 1, you have to flip this with respect to x-axis. And this is what you get. This is the absolute value of x squared minus 1, which in turn can be written as 1 minus x squared. So this is my y equals to absolute value of x squared minus 1. And in simpler form, we can write it this way. And for the rest of it, it is positive. It means that on the left-hand side, before -1, just need to copy down this curve, which is x squared minus 1. The same on the right-hand side. On the right-hand side also, it is x squared minus 1. So now it helps me to actually calculate the definite integral easier. I visualize the absolute value, I know how it behaves, so I can calculate the definite integral. But remember that your definite integral is between -2 to 3. From -2 to -1, you are on the left part, which is this part here. So here we go. The integral can be written as the integral between -2 to -1 of x squared minus 1 dx plus the second integral is between -1 and 1, just this guy here. The integral between -1 and 1, remember that we flip this, so you have 1 minus x squared dx, and finally we have the third integral, which is on the right hand side between 1 to 3 plus the integral 1 to 3 of x squared minus 1 dx. So now that you broke down this integral into 3 pieces, you can easily do the calculation. The very first integral is x cubed divided by 3 minus x. Your x is bounded between -2 and -1. The middle integral is x minus x cubed divided by 3. X ranges between -1 and 1. And your last integral is x cubed divided by 3 minus x. And your x is bounded between 1 and 3. The rest is algebra. So this guy is a third, negative a third, plus 1, minus, now plug in -2, you get -8 divided by 3, plus 2, the middle integral, it is 1 minus a third, minus -1, plus a third, and the last integral is, okay, you have 9 minus 3, minus a third, minus 1. Perfect. So let us do the algebra. It becomes, so if you take common denominator here, or maybe we can simplify this guy first, then take the common denominator. You get negative a third plus 1, and you have plus 8 over 3 minus 2. And the middle integral is 1 minus a third plus 1 minus a third plus the third integral, 6 minus a third plus 1. In turns, it can be written as, so if you combine these two, you get -1. If you combine these two, you get 7 divided by 3 plus, so you have 2 minus 2/3, and this guy can be written as 7 minus a third. So let's see if we can combine anything else. This guy is equal to, so here you have -1 plus 2, which is 1, plus 7, which is 8, and let me see. And here you have 7 over 3 minus 2/3, which is 5 over 3. 5 over 3 minus a third becomes 4 over 3. So if you take common denominator between them, 24 plus 4, or 28 divided by 3. So we broke down this absolute value into smaller pieces so we can analyze the definite integral, and we divided that into 3 integrals.